Okay, so at this point we've got a cell membrane that's at -80. We've got voltage-gated potassium channels open. There are voltage-gated sodium channels here, but their inactivation gates are closed. There are potassium leak channels, so there's two ways for potassium to leave, and there are secondary active transporters. There's actually some other ways for sodium to get in, bringing in things like glucose and amino acids. So we have potassium leaving, sodium coming in, and we're at -80 millivolts. At this point in the action potential, the voltage-gated potassium channels close, so we stop losing potassium. That ought to tell you, if there's less potassium leaving, we ought to get less negative, right? If we're having as fewer positives, some potassiums are trapped in here. If this potassium is trapped in, we might go to -79. Okay? And at some point, and we're going to keep holding some potassium inside until we get back to the situation in which we started, in which we have some sodium coming in, some potassium leaving, a little more potassium leaving than sodium coming in. So this goes until we're back to about -70 millivolts. At -70 millivolts, we're back at our same position with potassium leak channels with some ways for sodium to get in. So we're at -70, closer to the equilibrium for potassium than sodium, but not all the way because of that sodium coming in. At this point in an action potential, we're in what's called the refractory period. We're back to -70, but we can't get a new action potential because these inactivation gates are closed. So at this point, even though we're back at -70, we can't get a new action potential until over time, and we're talking maybe a few milliseconds here, depends a little on the cell, those gates swing back open and the activation gates wind up being closed, and at that point we're back to our original situation. So let me sketch that for you. So now we're at a situation where we have voltage-gated sodium channels. Their activation gates are closed, their inactivation gates are open. We have voltage-gated potassium channels, and they're closed. We have leak channels, potassium leak channels, they're open, so potassium is leaving. And we have secondary active transporters that are bringing some sodium in, along with things like glucose and amino acids. Okay, so that's a voltage-gated Na+, voltage-gated K+, K+ leak, and secondary active transport. Once these inactivation gates open back up, after these open, the refractory period is over. And at this point, we're back to where we started. We have voltage-gated sodium channels ready to go, voltage-gated potassium channels ready to go, and potassium leak and sodium secondary active transporters.